Hello world, and welcome to this special edition of Tech on Fire with Blaze. I'm Blaze Stewart, an architect at Winelect, and last night I had the special privilege of speaking at the local Software Development Meetup here in Richmond, Virginia. I was able to speak about the Internet of Things, and I gave special attention to the Internet side of the Internet of Things, and talked about all the things that go into making IoT solutions work from architecturally, and then did an end-to-end demo about how these things work. It was a fun meetup, so I enjoyed doing it, and I recorded it so you can enjoy it here. It's a little long, but I think it will give you some useful information on how IoT solutions work, and then maybe it's kind of a trivial demo, but one that will kind of solidify the concepts.
Tonight we're going to be talking about putting the I back in IoT. All that to say is, so much of the talk around Internet of Things, typically you go to a meetup like this, or if you go to any kind of talk about IoT, they're going to have a myriad of devices out there, and it's all going to be like talking about your cool devices and what you built on devices. And so if you're expecting that, I'm sorry, I just brought one Raspberry Pi with, and so my demos are not real high tech or whatever. It's using I just brought one device, and I really didn't want to focus on the devices as much as the internet side of the Internet of Things, which is really the architecture that goes into making IoT solutions work. And it does involve devices, but it's not. It's a lot more than just focusing on the Raspberry Pis and the Arduinos and the other Edisons and whatever boards you might have that you might be working with. So, what is IoT anyway? IoT, as it is it's a network of physical devices, vehicles, home appliances, embedded electronics, software, sensors, actuators, name it. If you could connect it to the internet, that's something that you might be able to call something that's part of the IoT, the Internet of Things. And these things are connected to the internet and exchange data, creating opportunities for more direct integration with the physical world into computer-based systems, resulting in efficiency improvement, economic benefits, and reduced human intervention, and more and less privacy. I forgot to add that part. But the Internet of Things really is anything that you can connect to the internet that is not that's something other than a cell phone or a laptop. Really, it's think about cars or even airplanes. So like a Tesla, for instance, has you can get a data plan for it, and it's got sensors all over it. Tesla can, from their cloud, push down updates to your car, and you not have anything to do with it. And like if you've probably read stories online, like during hurricanes, Tesla will kick on that premium upgrade for extra mileage that's built into the car, but you have to actually pay for it. It's disabled by default. Like on a Tesla, if you buy one, it might actually be able to go like 350 miles, but they don't let you go more than like 280 miles without actually paying for that extra mileage, even though the car will actually do that. But by software updates, yes, sir.
Is that total distance or is that per hour?
No, it's not total distance.
All right.
Oh, yeah. So they'll let you go like.
I know they're fast.
They're fast. They'll let you like the range. Like there's a cap on the range that some Teslas will have, and that what Tesla has done is, unless you pay them like $5,000 extra when you buy the car, they'll cap the range at 280 miles, even though the car will go 350 miles or something like that. But sometimes during hurricanes come into the Gulf of Mexico and you're trying to evacuate, Tesla will be nice and let you drive the 350-mile range and not have to pay for it. Then they'll shut it off. So after the hurricanes pass or whatever. So it's things like that. It's the ability to push down updates and do things from the cloud down to the device, as much as it is about being able to take stuff from the device and send it up to the cloud. So it's kind of a two-way street. And like I said, it does destroy your privacy some. If you've got your phone on, it's probably tracking you and you didn't even know it. And Apple and Google have gotten hot water over that in the past. In any case, so the architecture for this is like a reference architecture, if you will, for IoT. And the Internet of Things is, yes, it's IoT, it's devices, it's the IoT platform, and it's the enterprise. So you have these three kind of domains, if you will. There's the IoT portion that we're going to talk about, and then we're going to talk about this middle piece, the IoT platform, and then we're going to infer the enterprise. I'm not going to get into the big data side of this because that really gets domain specific depending on what you're talking about. But the edge the IoT itself and how the IoT platform works is going to be fairly consistent across all applications. And it's how you customize it to your domain that really makes it work. So regardless of how you use IoT, inevitably it's all going to end up looking something like this as a reference architecture. You're going to have some kind of device, some kind of connectivity, some kind of messaging platform in the middle, and then you're going to have some kind of enterprise analysis of that data, exposing that data, using some kind of APIs to access that data. There's all kinds of things that you can do on the enterprise side with this. But it's mostly, I'm going to be focusing on the left one and the middle one here tonight. So that's kind of an overview of what IoT is. Does that make sense? It's not rocket science. It's pretty straightforward. But it's not strictly the devices. That's mostly what I'm going to kind of communicate. The devices are actually a very small part of it. So what are IoT devices anyway? They look, that's a picture of a Raspberry Pi. They come in all shapes and sizes. Like I said, planes, anything from an airplane flying through the sky to a little dev board. I got a Raspberry Pi here. Well, it's kind of tethered, so I can't show you, but it looks like that. There's a picture of it. But that's actually that's a Model A version 2. That's actually newer than the one I have here tonight. So that's a Raspberry Pi. They all kind of look the same. But what the cool thing about these devices is there's just SDKs for them. There's SDKs in practically every language that's popular. So if you like C, C++, C#, Node, Python, Java, odds are you can find some IoT SDK for building IoT applications on your devices with. So the one I'm going to be using tonight is Node.js, just because I like Node.js and it was easy to do a quick demo with Node.js. However, if I was going to go more like hardcore and like really efficient, I would probably write it in C. I did some IoT projects for a customer, and I did most of the work in C. Although I'm really not a C programmer, I did a lot of the work making it work in C just because it's so low level and it's very efficient. But Node.js is heavy, and but on a Raspberry Pi that doesn't really matter. It works fine. It's powerful enough to run it, and devices can use a connection string to and an SDK to simplify development. So in the past, doing IoT development was a lot more manual, but now with all these SDKs in whatever language you're using on the device you want to use, and using whatever platform you're using, whether it be Azure, Google, AWS, their IoT offerings, they're almost always going to work a lot like an SDK with a connection string to bring them together. And then all you really have to do then is write your code using their SDK. And they take all of the hard work out of building IoT solutions, which is how am I going to connect this device to the internet? How am I going to register this device securely? How am I going to know where to send my data? And how am I going to work with all those low-level protocols to take care of all this? And all that work is hard if you've never done it. If you have done it, you know what I'm talking about. If you've never done it, it's getting down and dirty with like C, trying to do HTTP calls, for instance, can be a little bit arduous, or MQTT calls, for instance. All these SDKs take all that work out of it and just make sure that you can focus in on trying to make your device work without having to worry about making everything down to the metal work. And if you like doing that, it's you can do it if you want. But for the most part, it's just, if you just want to be a creator and focus on building your device, having all your sensors hook up to your GPIO pins, all these SDKs will provide that, and the SDKs are connected to the cloud are there, and you just basically are building a bridge to take whatever data that you're collecting from your sensors and then shipping that up to the cloud somehow. That's really what these SDKs do. So, any questions about that?
Hello.
Yes.
Question. So, it looks like in this classification of IoT devices, then the devices should have a processor and internet, obviously some kind of connectivity and or memory and all that stuff. So is that an expectation? Is that like the minimum qualification? Or?
I wouldn't say it's a minimum qualification. Like, to connect to the internet, it's got to support some kind of connectivity, and some devices don't need a full-blown operating system to work. Like, if you want to get some really, really lean devices, you can. I'm just saying those are usually really niche devices that are being custom made for whatever the application is. Like most of the general purpose devices like Pis, Arduinos, Edison boards and all that are going to run some version of Linux, and they're going to have a GPIO array on them that you can plug in, sensors and stuff like that to it. So it's not required to do it, but it does make it a lot easier to do it. How's that? And in some cases, some devices, which I'm going to talk about the cases for this in a moment, they can't communicate with the internet, and they use old protocols like serial. And there are use cases where you can connect those up to the internet, but it's using what we call an IoT Edge, the appliance, to do that connectivity. It essentially just stands in the place of the device. Some devices use those, like you can take a Raspberry Pi and still use it with an Edge, but you can also take like an old dumb terminal that uses RS-232 or something like that, serial, and then connect that to some kind of appliance, and then it just relays that data onto the cloud for you. So that makes sense? So yeah, any modern application is probably going to have some baseline minimal OS, minimal kernel, with some, it just makes development so much faster, and they're mass produced too. So what's an Arduino cost now? Like 10, 15 bucks or something?
Yeah,
20
at most.
Yeah, so and Raspberry Pis are like 20 for 25 bucks. That's much cheaper than trying to build a custom board for your application. So I saw a billboard, and I wish I had a picture of it, but there was a billboard that they were using Raspberry Pis to drive billboards, like those big slide flipping billboards. They had connected a $25 dev board to drive this $100,000 billboard, and the only reason that it was a Raspberry Pi was because it was on the boot screen, and it showed the Raspberry Pi logo on it on the boot screen. I wish I had a picture of it, but I saw it.
Awesome.
It was I was like, that's pretty cool, because they're building these humongous $100,000 screens and hooking a $25 dev board to drive it. Just yeah, it's all it's got to do is show a picture, right? That's perfect for that. But in any case, just some quick stats about these things. And I found these kind of be interesting. There's more devices, more IoT devices, than there are people on the planet. There's 20 billion of these things by 2020. That's a year. These are current stats. These aren't like, I think I got these a few days ago. So this was published in 2019 by Gartner. Gartner thinks there will be about 20 billion of these things in 2020 within a year. By 2020, 90% of automobiles will be connected to the internet. I think that's new automobiles, not old ones. I drive like a 15-year-old car. It's barely connected to it's barely got a computer in it, much less an internet connection in it. But I guess if you count the phone that you're running in the phone to the car, you could say that it's connected to the internet. But yeah, my old Civic doesn't have the internet connection. Companies will invest $15 trillion between 2017 and 2025 in IoT. That was a pretty staggering number. That's like the deficit. The United States debt is like what, 13 trillion now? That's a lot of money. And I really don't know what $1 million looks like, much less $1 billion, but $1 trillion. That's like more than the GDP of most countries in the world. In any case. Every second, there's 127 devices connected to the internet. New devices are connected to the internet. So every second, that's a lot. Okay. That's adding up really quickly. And the IoT devices are expected to add another $14 trillion to the global economy by 2030. So, take that investment, extrapolate it over over the next 10 years, $14 trillion into the global economy. So this inevitably is going to impact us all, because if you have like anything at your home that's connected, be it a refrigerator, a washer, dryer, or a dishwasher, alarm system, or a robot vacuum, thermostat. I have, what do I have in my house? I have a thermostat that's IoT. I have a robot, I have a Roomba, so I guess that's IoT. And then I have an alarm system. So yeah, that's IoT as well. So I have at least 3 applications of that are IoT. Not to mention all my Raspberry Pis that are my personal stuff, but that's just stuff I bought. That it's consumer electronics that are part of this makeup here. So pretty interesting stuff. A lot of stuff, a lot of applications being built for this.
Blaze, what's that doing to the saturation on the internet? I mean,
I'm not sure. I've never bothered to look up the statistics of what percentage of traffic is IoT versus what is people watching YouTube or looking at Facebook. But I imagine it's pretty hefty. The other thing about IoT though is usually the payloads are tiny. So while it might generate a lot of noise, like a lot of connections, I don't know how it's generating a large volume of traffic in terms of like megabytes, because it's not streaming video or. Well, I guess it could, but yeah, it could. But
Smart fridge, man.
so what?
Smart fridge.
Smart fridge.
And my wife wanted to spend $3,000 on a smart fridge. Bought her a tablet and take it to the door.
The question is
Refrigerator.
how much traffic does it take to say you're out of milk?
Exactly.
Yeah.
As it sends me a picture.
It does? It sends you a picture of the interior of the fridge? That's awesome.
I've seen those at
it's like
the
on
Best
or
Buy.
off.
You
Age old question.
can actually cut the light on.
That's cool.
Oh, yeah, remotely.
That's right. Yeah. And I thought it was cool when I could actually access my laptop from my home, but now it's like everything's like.
Yeah, I get text messages when my garage door opens.
Yeah.
I can set the thermostat any way I want it.
Yeah, I can turn my vacuum on when I leave. I just go onto the app and start vacuuming my floors, and it just starts going around. Then control the temperature when I'm away.
Yeah.
The alarm I can set for my phone, so it's it tells me when I get text messages when stuff happens. And Roomba sends me a message. Oh, your floor's clean. Great. Or it tells me when it's stuck too.
Yeah.
It tells me when it gets stuck under the couch or something like that.
We got the wrong kind of furniture because we used to have a room, but it got stuck every time.
Yeah.
They got rid of it.
So I like my Roomba. Actually, even when it gets stuck, I'm just too lazy to do the floors. I guess it doesn't get stuck every time. So far, it's been a good purchase for us. In any case, a lot of stuff going on in the IoT device space. Can't hardly ignore it anymore. So we talked about devices. Let's talk about device messaging for a minute, which is it's how the devices communicate with the cloud. And this is where it starts to get into the Internet of Things, the Internet piece of it. So device messaging has cloud-side messaging platforms that brokers messaging between the cloud and between devices, the cloud and devices. So you have devices, your internet, your cloud applications that are like your enterprise applications that are consuming this, and the cloud and devices, which is your connection between the devices themselves. And so that's it's really focusing on this cloud side messaging platform that is the internet and the Internet of Things that makes all this work, and uses protocols like HTTP, AMQP over WebSockets, MQTT, and MQTT over WebSockets. There's actually other ones out there. So a lot of these protocols are widely supported. AMQP is heavy. How many of y'all have used that before? I hate using it. It's just because it's so heavy. But MQTT is a lot lighter if you're looking for a messaging platform. And then if you're getting stuck behind firewalls and stuff like that, MQTT and AQMP over WebSockets is a nice way to approach that, because that'll use port 80 or port 443 over SSL. So you can actually use these protocols without having to worry about firewalls getting in the way and things like that. So all these devices, all these device SDKs I mentioned earlier will typically implement some abstraction of all these different protocols. So you don't actually have to pick which one that you're using. You just kind of have to understand that I'm just sending a message, and then it will do all the work for you. And typically it's going to use MQTT or MQTT over WebSockets or HTTP or S to do that messaging. But you don't have to write HTTP calls or MQTT calls or AMQP calls. It's the SDKs will handle that for you if you're using an SDK on an IoT device. So the main thing to focus in on is just making your IoT device be able to relay that message to whatever suite you're using, and don't worry about all these details here. I'm just saying they're available. So if you have to deal with that in your IT shop to get around things like firewalls and so on. So There's two kinds of messaging. It really has to do with the direction they're going, and that's device to cloud and cloud to device, and they're typically abbreviated D to C and C to D. So D to C messaging is device to cloud messaging, and messaging. This is I'm talking about Azure here, but messaging received on the Azure IoT Hub can be routed to other messaging solutions like a service bus, event hubs, consumed directly through connectors on cloud-hosted code, and can be consumed direct by cloud-hosted code such as serverless events. How many of you guys are writing serverless now? So a couple folks are. If you're not writing serverless, it's pretty cool stuff, but especially if you're going to cloud, it's probably, I don't know about the cheapest way to do it, but it's certainly one of the most headache-free ways to do code in the cloud. You can probably testify to that.
Yeah, just watch out for noisy neighbors.
Yeah, it's true. But in any case, cloud-hosted code, like in serverless, is one popular way to consume messages because it's event-driven, and so serverless code is typically event-driven code. So some HTTP request, some service bus message, some timer goes off or something like that can trigger a serverless event, and the code that's in that serverless function, if you will, can do something with the message that's sent from the device. And so that's really where your custom code gets in play here, is in that serverless side of things. And most IoT solutions are going to kind of, they're not going to force you to do that, to use serverless, but they're going to highly encourage you to use serverless because it is event driven and it is message driven. So it's very asynchronous, it's very loosely coupled, it's got all the good stuff that you want in a highly scalable solution. You don't have to do server administration. There's a lot of advantages to going this way, and you can literally scale it to millions and millions of messages per second if you to handle the large IoT workloads, or it can handle even simple IoT workloads, such as a single Raspberry Pi that I'm going to be using tonight. So that's what I'm going to be demoing. But you can literally scale this out to millions of devices. And one of the customers I was working on did that. It was globally a global network of IoT devices, and they used Azure IoT Hub to broker all that, and it scaled really, really well because just the elasticity of the cloud and just the event-driven nature of the applications and all the serverless applications we wrote to respond to that was very efficient. So you didn't get caught up in trying to maintain servers. You have to go focus in on code and making that work because Microsoft provided all the SDKs and all the other stuff I'm talking about. And then the second kind of message is a C2D message, which is a cloud to device messages. And this allows you to do the cloud to push down messages to a device. Like the example I gave earlier, Tesla enabling that extra mileage on the car from their cloud. They just push down a message to the car, and then the car unlocks that feature, and then it allows you to drive further. So that same kind of thing can be done on these little dev boards, or whether or any other application that you want. So maybe in the future they'll be able to fix planes in the air while they're still flying before they crash or something like that.
I hope not.
Or, hot fixing an airplane, that would be bad.
Scary to think about that.
Yeah, but I guess if it's going wild like this, maybe you want an update. I don't know.
No.
Or maybe a parachute.
There you go.
There you go. In any case, so the cloud to device is just simply to notify the device of something that happened in the cloud. So it's a two-way communication between the device and the cloud, and the cloud device to the cloud, and the cloud to the device. So having that available on having the devices listening for messages is just as important as having them send messages. That's kind of the thing. And if you can't talk to the device from the cloud, then it really doesn't give you a whole lot of power to respond to something that the device might send up. So say, for example, a lot of buildings nowadays are hooking up these little sprayers to IoT devices, and so the fire suppression system in the building is all IoT driven. So these are probably made by Johnson Controls, because they make most of them. There's other companies, but Johnson Controls has an entire IoT solution where these things are triggered by some fire detector that is in the building and sends up some device, some message to the cloud, and then it can then send a message back down to all the control boards for these fire suppression to turn them on without ever having to have human intervention, and also call the fire department. So that's the ability to turn them on in the building, as well as receive telemetry from the fire, the smoke detectors and all that, to is it a false positive or is it really truly a fire? That kind of stuff is what IoT is getting into for automating things like that. So I want to talk about the IoT Edge because it's kind of the next step in these when you talk about IoT connected devices. So it is possible for a device to talk directly to a cloud solution by way of messaging, but increasingly, as these solutions grow and grow and grow, especially for large deployments of devices in a single location, they'll typically deploy something called an edge device or gateway device. They'll call it different things, but basically the point of it is to act as a proxy between all the devices that are on the premise that it's monitoring and the actual cloud itself. So if I'm using Azure, for instance, the IoT Edge there would act as a proxy for all these other devices I have on premise. So if you imagine if you have a factory that's building something, and that factory's got sensors on all of the robots that are building this equipment, and you don't want all those robots independently connecting to the internet and having just a flood of connections. Rather, what you want to do is run those through a proxy server like an IoT Edge, and then what that IoT Edge then will do is broker their communication back to the cloud side. And there's some advantages to doing this, and it allows faster response times to events in the event that there's a drop in the internet connection, or if you need sub-millisecond response time to some event in the environment. You can put that kind of collation of data onto the IoT device, IoT Edge, rather than having to do that in the cloud. And in the instance of like a fire suppression system, if you have your smoke detectors going off and you have thermometers that are the infrared sensors that show it's a fire, then you can have the IoT solution that's acting in the edge case there actually turn on the sprinklers to do the fire suppression, rather than actually have to do all that in the cloud. And you can apply AI to evaluate data and do all that kind of stuff on that edge, which would be very hard to do if you're doing it on one of the edge actual devices themselves, because those are typically low power. It would be very hard to do AI on a Raspberry Pi at the scale what you would need to manage that plant. But imagine if you had a rack-mounted server that you could throw in a rack that had a lot of RAM and CPU horsepower to do all that. You very well could do it there. So that's what that edge appliance is really going to be for. It can handle network disruptions, which I already mentioned. Imagine, in a fire, for whatever reason, the connection gets cut. You can have the actual IoT Edge take over for what the cloud's doing and stand in its place. It can also queue up messages. So these devices are sending messages. If the internet connection is down, it can queue those messages up until whenever connections get reestablished, relay those onto the cloud for consumption there. And then it can lower cloud consumption by way of filtering. And this is actually a really popular use case for this. It's to kind of filter out some of the noise that IoT devices generate, because IoT devices can create lots and lots of messages, and not all of those are going to be relevant to every application. And you might just want to get a subset of those messages and actually send those up to the cloud. And in that case, you can actually put filtering in on all your devices, and then just filter the messages, and then send up what's important for your applications that are consuming that data that those messages are sending. And Edge, and the other thing about these edges, they also give some extensibility to where you can bring your own code to the edge as well. And typically these have some way of extensibility built into the platform. So the one from Microsoft, for instance, is all based on Docker. So you can basically bring your own container and then extend the Microsoft's baseline IoT offering by adding a Docker container to that environment that will add some kind of feature set to the IoT Edge that they're producing to add functionality to it. Now, that functionality is your custom code, so it's domain specific usually, but in any case, it does have the ability to bring your own code. And they can also be Azure functions as Stream Analytics, or on the other clouds that will have some AI applications that you can bake into the platform there as well. So these edge devices give you the ability to have some analysis that are going on locally rather than in the cloud. It doesn't give you all the data if you have multiple edges deployed across a wide geographic area. You're not going to have all the data available from every location. I guess you could if you downloaded it, but with the IoT Edge device, you can at least act on the data that's coming out of your environment that one's proxying. So with that in mind, that's kind of the middle piece, the edge piece, and I want to talk about device management now, which is the how do you get devices on the IoT on an IoT solution. Now, these integral to any device IoT solution is the ability to manage these at scale, and this is typically where your cloud solution really comes in handy, regardless of whether you're a developer or you're a system administrator or you're just trying to figure stuff out. Having this ability to manage devices at scale is going to take the headache of updating devices. It's going to take the headache out of like security and all of that. So you need a platform to manage millions of devices if you're going to go to that scale. And that's where these device management solutions really shine, because it bridges not only the messaging platform, but also the management of that messaging platform, and then the connectivity between devices and that messaging platform. So it's brokering all those relationships without having to write a lot of code or having to build a lot of infrastructure to do that. So they integrate with messaging, they ease provisioning, security, updating, and device provisioning. And that's stuff I just mentioned a moment ago. But the point is that it's just about integrating all of that together into one solution that gives you a dashboard, essentially, where you can go in and figure stuff out to spin up new devices, shut down old ones, and do some kind of querying against all the data that's coming out of those, just to see what's going on in the environment, or to provision entirely new edge systems and all those other things I've just talked about. So device settings can be pushed from the cloud. That's part of that messaging platform, that cloud to device messaging. That's part of the device management that goes into this. And security features can be enabled on these solutions to authenticate devices as well. So these are kind of two things that provide management features that these management suites provide, particularly this first one. So every device is going to have its own set of settings that you need to push down to that device, and that's typically called device twinning. What it does is it allows you to configure every device uniquely on that particular solution, while trying to do that manually through a custom solution would be a little bit more arduous. But having the ability to push down settings to a device is a nice nicety. Or if you need to change the setting on the device, for instance, you could easily push that down as well with a new update. And then authentication and security is another big deal with IoT devices. You don't want just any rogue device connecting to your Internet of Things suite. So these things do things like 501, X509 certificates. You can do pre-shared key authentication and things like that to help secure the devices and also authenticate those devices when they do connect to your IoT suites. So the device management suite does manage all that for you. So device provisioning is part of this, and it's the part of the onboarding process for new devices. So think about whenever you buy a new appliance, right, and you want to connect it to the cloud, you usually have to go through some wizard on the device to fill out your email and register the device. And part of that process is the device provisioning process. So what it's doing behind the scenes is connecting that device up to an IoT suite, whatever it might be. So when I registered my security system with SimpliSafe, I had to basically just go online, and then there was a code on the bottom of the home device, the base station, and I had to punch that into a web form, and then a few minutes later, the device starts saying, now you can connect your devices. I'm like, okay, they just pushed down an update to that device and connected it with me. They went and registered with my address, and then with my jurisdiction for calling the police, the fire department if there's something wrong, and all that. It's just part of that registration process. But all that to say is they have that's part of the device provisioning. And they could have shipped that device anywhere, and they could have anybody could have bought that device. That's kind of the reason why you need this device provisioning. They're not going to ship that device with my settings on it. They're going to ship that device just as generic, and then by a registration process, you're going to be able to go through device provisioning. And typically the way that looks is going to look something like this. A device is started with the factory settings. So it comes with, by default, with some kind of factory settings. And then what that does is it notifies a context the device provisioning service when you turn that device on. And it says, okay, I'm here. And then the device says, it registers with it some kind of device management suite. It registers that device. Okay, here's a new device. And that usually means it sets up the security for that device. It might create certificates. It might generate keys. It's going to register a new endpoint for that device to talk to. It's on the message bus and do all that kind of stuff. And all that's automatically done once the device connects to this divisioning service. Now, once that happens, the device receives data from the cloud saying your device is all ready to go. Now you can connect to the cloud, and here's your endpoint. Here's your credentials. Here's all the things you need to connect to the cloud. And so that gets pushed down by way of this device provisioning service. And so once that happens, the device then can start sending telemetry back to the cloud, and the cloud can start sending messages back down to the device as well. So it's pretty straightforward on how that works. But going through this device provisioning workflow is all about managing that device at scale. And so, say I sell the device, and I want to, and the next user gets the device, and they go through I do a factory reset on it. They go through the same process. It's going to register that new device and get new credentials and new settings for that device. That go through this whole process all over again by doing a factory reset. So it's just, and you've probably been through a process very similar to this whenever you bought a new phone, or you bought a new smart TV, or anything like that, or bought a smart refrigerator. They all kind of go through this device provisioning loop in order to connect your device with your settings to whatever cloud that is managing that device, whether it be Amazon, Azure, Google, or some homegrown cloud. The point is, it all kind of works this way. And device management is that process of doing that and being able to broker all that relationship. So now I want to do a brief demo. Now this demo is kind of an end-to-end demo, and the demo itself is fairly straightforward. I have a device, and my device is a Raspberry Pi. It's a camera. And what it is doing is basically doing motion detection. And what it's going to do is, I have my device here on the left. It's going to do motion detection, and then what it's going to do is connect up to Azure. So I'm going to use Azure's IoT suite to do all this stuff over here on the right. So when I turn the device on, it's just going to connect to the IoT hub. That's the messaging platform on Azure for doing all the device to cloud and cloud to device messaging. It centralizes that. And then when I turn the device on, what I'm going to do is I'm actually going to turn it on to the cloud. And then it's going to turn the device on. And then once the device is turned on, it's going to start trying to do motion detection. And once it detects motion, what it's going to do then is it's going to take the picture, take a picture, and then upload that picture to storage in the cloud. And then once that picture is uploaded, it's going to send a message, a cloud to device message. Device to cloud message that's going to be put on a service bus, which is going to kick off a serverless function. And then what that's going to do is then it's going to notify me that my little IoT device here detected some kind of motion. So there's a lot of moving pieces. So I want to walk through this just to kind of give you some idea of what this actually looks like. So this is my my dev board right here. It's you can't really see it. It's kind of because it's tethered, but it's a Raspberry Pi. It's tethered to my laptop for power and for internet connection. So let's see if I can pick up the camera. Here's the camera. It's just a little USB webcam, so it's nothing special. It's not like it's soldered on the board or anything.
You just use like a crossover cable and stuff that
yeah.
you're sharing?
Yeah, that's all I did for this. I mean, I had it plugged in my router at home, but Here I just set up internet connection sharing, and I need my actors here to help me out. I have my threat here. It's a lion, and then I have the police. This is Chase from Paw Patrol. So Chase is on the case.
Nice.
So those are my actors. Sorry. So I'm going to use those for my motion detection here in a minute. Those are my actors. So I have 2 girls, and these are bath toys. I just sold them. So they're going to be like, "Where's my lion tonight?" And they take the bath. I said, "Daddy's got it. He's using it to tell people about Internet of Things." Yeah.
Stranger Things.
My last time I did a demo, a similar talk on IoT. I had a pink castle, and I had a little police figurine and a bear. So so these were the characters that got elected this time. I couldn't find my daughter's pink castle, or I would have brought that just for effect, but I couldn't. So what?
Oh, we did it.
Probably did. He's like, "Daddy, why are you taking my castle?" Word. I need it for a demo. So whatever. It was fun, but I did steal their bath toys, so they probably won't miss them. They got thousands of toys. This will be the one night they'll ask where it is. But in any case, this is the architecture. So let's go over to Azure, and let's look at the code for this first. I'm going to show you the IoT code first. The code I have running on this Raspberry Pi is actually really straightforward. Here it is. Now, I wrote this in Jet. Since this is a software development meetup, I figured it'd be nice to show you some code. That'd be kind of fun. Since I'm assuming you came to a software development meetup to learn about software, not just some guy yakking about lions and dogs. But this is written in JavaScript, so it's Node.js, and this is just pretty straightforward. All this is doing is using an SDK from Azure, from Microsoft, and that's what this Azure IoT Device SDK is. And it's using some classes some packages out of that, and then I'm using some wrapper around a motion detection daemon that I'm running on the Pi here, and so. The motion detection daemon is actually another application that's called Motion. It's an open source project. Rather than integrate with that, I just wrote a wrapper around it because that was easier. And then it's just, once it connects up, I can turn it on. That's where there's messages. So I can push down a message from the cloud, say on, and it will turn on the motion detection. Or if I say off, I can turn it off. And it's just, really all it's doing is killing the process on the host. But kind of a low-tech solution, but it really does work. And then this method down here, all it's doing is polling for the output of that camera. And so if the camera actually picks up motion, this is polling for the files it drops onto the drive, onto the storage. And typically, if I was going to run this like a more high availability solution, I wouldn't be doing it this way. I would probably use some kind of piping and all that, but I didn't have time to go figure that out. This was a low-tech solution, so that's why I did it this way. But in any case, all this does is it gets those devices and then uploads them to storage, and then it sends a message right here. It says new message, content coding, sending messages, and it says getting message data, and it says send event message. And that's where it sends the message from my device up to the cloud, but up here it's actually doing some stuff to check for the files. Are there new files? And if it finds new files that the camera creates, then it uploads those files first, and then after that it sends a message saying, here's a list of the files I just uploaded. And then that is where it gets to the cloud. So let's flip over to the cloud, and I'm going to pull up Azure. And log in here. I have to change accounts. Put my dev account here. I've got too many Azure subscriptions.
Yeah, me too.
Okay, all right, let's see if I can make it bigger. How's that? Is that better? All right, good. let's go over here to my resource group. And I put all this into one resource group on Azure. How many of you guys are using Azure now? How many of y'all are using AWS? Shame on you. No. I'm joking.
It's all good.
That's all good. I'm just
We'll try to reform our ways after tonight.
Never still need 3 legs.
No.
We're just waiting on Google.
We need competition. That's what keeps Azure going. Is if Azure does something, AWS follows. If AWS does something, Azure follows. I mean, they're just it's tit for tat every time they come up with a new feature. The other one's got to have it, and it really does. It's driving cloud innovation at neck break speeds. But I need maybe take this down a little bit. Where's my scroll bar? Okay. So all I have on this this IoT solution here is let me go full screen here. I have some resources defined here, and that's what all these are. They're on Azure, they're called resources, and they're in a resource group. And this is my resource group. And what these are is this is a service bus for handling messaging. It's just like any other service bus. You have topics and queues and that kind of thing. It's just a messaging platform. This is the IoT Hub, which is the management suite on Azure for managing IoT solutions. And then I have a SendGrid. This is just basically an email or a multi-platform, multimedia messaging service or something. Mostly used for sending email. And this is a serverless application. It's a serverless function written in Azure Functions. We're using JavaScript as well. And then this is just a storage account where I'm storing those images. So anytime that I upload images, they get stored in a storage account, which is just blob storage. It's just byte where you can store files or text documents, anything like that. And I'm using that to store the images that my device is capturing. So let's drill down into this IoT Hub here, which is where everything this is where all the glue comes together. This is the thing that kind of bolts all this together. And what I have here is a lot of things. I can't, for the sake of time, I won't go into all of these, but notice I did talk about IoT Edges, and this is where you can configure those, and the IoT Device Configuration for device management. And that's where you can get all that device provisioning and all that going on, which I'm not going to be able to do that for the sake of time tonight. But I do want to look at IoT devices here, because this is where I could go in and I could see all my devices that I have that are connected to this particular IoT Hub. And in this case, I have my IoT Hub configured to use, set up to receive messages from my Raspberry Pi here. And I provisioned this morning to set this all up. And there's all the stuff that I can use to configure it. There's my connection strings, there's my keys. You can take a snapshot of this, but I'm going to go home and delete it, so you can't use my hub. Sorry. So there's all my keys and all that. But in any case, I can send messages from here, but I can also receive messages here as well. And by using some of these other features. I'm going to use a message later on and actually run this demo. But here's where the device twinning is where I can send settings down to the device or update settings on the device and do things like that. I can receive, send messages to the device, and I can monitor the device from here as well. So that's kind of the, and then the IoT Hub connects to, I need to go to my hub. This is where I can connect it to my, where is it? Message routing, that's where it is. I can connect it to my service bus. So now I have direct messages queued up to go to an endpoint that I have configured on the service bus. It's just a topic, a queue, message bus queue, which is, and then from there, I can also upload files to that storage account I created by here. So I just got this. I have this configured to send up files to that storage account. So from my device, when it's doing its thing, it uploads the devices to the storage account I have defined here first. That's where the files are stored. And when the files are uploaded, it will then turn around and then send a message back to this message routing that it's going to send on. It's going to relay onto that service bus that I have configured out here in my resource group. And just to show you what that looks like, the service bus is fairly straightforward. There's nothing nothing about this that's particularly earth-shattering. I have a bunch of queues here that are defined, and there's as soon as that pulls up, it's just my queue that's defined. And so what I can do with this queue then is I can wire up my serverless application to listen for things that are coming in on this message queue. So that's what I'd have here. So back here on my resource group, I have my serverless function right here. So I'm going to take a look at this. This is my serverless function that's written in JavaScript. You can write, like, just because I wrote this in JavaScript doesn't mean you can't write these in any language that this supports. I think Azure is supporting Java, JavaScript, C#, Python. I think you can write PowerShell functions now. And there's multiple SDKs for this as well. All I would say is it doesn't really, just because I chose JavaScript, it's just because I'm, again, quick and dirty kind of thing. If I was going to write a more production, like more scalable, I would probably go with C# on the functions like this, just because it's compiled code. This is interpreted, so it's slower. But all this is really doing is listening for a message, and that gets sent in, okay? And this is the message that gets sent in, and I have it connected to that service bus by way of integration here. So there's my service bus trigger that gets triggered when a new message is queued up onto that service bus. It triggers this function, and then I have an output that's SendGrid. My output and SendGrid is just it's going to send me an email. That's all it's going to do. Okay, and so the code, what it's doing then is it's getting that integration is basically taking the message that gets sent from the device up to the hub, the IoT hub. Then it gets put onto the service bus queue. The service bus queue then triggers this event, and this receives it as an object. This function then parses out the object, the message, and then wires it up. Then basically creates a message, HTML message with the images that got uploaded embedded in that message, and then it sends it to me by way of email. So I'm getting notifications by way of email. I could have done like an SMS push, or I could have done written a mobile app to do this. Point is that you can send out notifications or do any other kind of integration this way. You don't even have to use a function to do this. You could use any kind of ETL solution that would connect to a service bus. ETL solutions do that well, like Azure Data Factory or Logic App, or any kind of thing that can respond to messages on a message bus. I mean, it's pretty much anything that's code or otherwise nowadays. In fact, you could probably even use SQL Server integration services if you want to just write it to a database or something like that, or Oracle integration services. I mean, it's really, at this point, when you get to this point, this is really where it stops. It stops being more. The IoT part of it ends, and it's really more about what you're doing with that data. That's your enterprise side. So in this instance, I'm kind of getting out of the IoT space just so I can have an end-to-end demo to show you as well. So with that in mind, let's see if I can actually make this work. So that's the overview of the code. So I've already SSH'd into this Pi here. I need to make this bigger so you can see it. Hey, that's better.
Nice.
Perfect. All right, good. Because I want you to see the telemetry that what this is doing. I mean, because it's gonna. So here I have my device. It's connected. Let me make sure it's connected to the internet first. It should be. Okay, we're good. All right, we're connected to the internet. This is a Raspberry Pi running Linux. I'm running Ubuntu Core on this, which is IoT customized. It's a specific version of Ubuntu for writing IoT solutions, and running on Raspberry Pi 2, which is it's an older one. You get Raspberry Pi 3 and 0, but it doesn't really matter. They all kind of work the same way. And this has got an Ethernet cable plugged into my laptop, and then it's got my USB camera here. And so let's see if I can make this work. So to make this work, I'm gonna start the application. Okay, it's starting the daemon. And what that 0 is doing is that's telling me the number, that's the image count that it detects. That's just so I have something going on. And the client connected, that piece is saying I was able to connect to Azure. So it is connected to Azure at this point. So I'm going to go back onto Azure, and I'm going to turn on the camera from Azure. And it's on. Now, let's see. Let's go look at the. Okay, it's on. Now let's see if the line can set off my motion detector. Okay. Oh, something happened.
You got a 2.
Yeah. Okay. Just sent. It's uploading a bunch of pictures now, and so I should get a message. Like that first message, it says sending. It shows send up the first 2 pictures, and then I'm probably going to get a big message with 19 pictures on it now, because the lion set off the motion detector, and then I'm going to dispatch Chase to go check out the situation. 31 pictures. Oh, grief.
You might be detecting your motion too.
Well, I got the camera pointed over there, so unless Kevin is in the frame, which I don't think he is.
Oh, there we go. You saw it. He is.
But here's what I can do. I can turn it off. So it's not doing anymore. It's still uploading images, but I turned it off. You can see the motion detection off. Now I just got to wait for the message to come in. And then I'll pull it up on Outlook and should be able to see it. Yeah, it's uploading a bunch. It captured a bunch of images. Okay, I think the first message came in.
This is 30 frames a second.
I thought I had it set for 2 frames per second, but maybe not. Okay, it finally got them all uploaded, and there's our lion coming into the frame. So, but you kind of get the point. So that was the notification I got there. So, and then here's another message with more images.
Pulling it back out.
Yeah. He's still in the frame. But you can see how that works. So and there's me typing on the keyboard, which is probably why it set off a bunch of. I was trying to get out of the frame, but I guess I was still in it. So I'm here. I am trying to turn things off, and here, there you go. But you get the point. Okay, the IoT images are now the IoT solution is working by sending doing motion detection to send messages up to the cloud and then send me a message. The whole architecture works end to end. So to kind of recap that, let me go back to that architecture slide, just so we can kind of review it based on the demo. So it basically, you saw it, the device captured an image, and then it sent that image through IoT Hub up to the storage. And it would do that for every image it captured until it exhausted that queue of images, essentially. And then after it's uploaded all the images, it then sent a message to the IoT Hub, and then that got relayed onto the service bus. Okay, and then the service bus caused a trigger to fire, which then fired the function, which took all the images from the blob storage and then built an HTML message and then sent that message by way of email, and that's what we pulled up in Outlook. And then you saw the images there that were captured. So all in all, it's a fairly basic demo, but it does give you an idea how the Internet of Things works, because I have it on my device. I have my device management piece in the middle, which is my IoT hub, and then it's got connected to that my messaging platform, which is my service bus, and my storage, which is my blob storage, and then my enterprise integration, which would be my function app and my SendGrid. So it's a trivial demo, but it does encapsulate everything we saw in that reference architecture at the beginning of the talk, where we had on the left we had IoT devices and edges, in the middle we had the IoT suites, and on the right we had the enterprise applications. But in all, that's how the Internet of Things is designed to work, is using that kind of architecture. And so you don't have to be a guru in electrical engineering to be into IoT. I like to actually deal more with play with the stuff on the right side more, particularly the internet, the cloud side of things, because I love the cloud stuff. But the enterprise side of things as well. If you're like into data and AI, you can definitely play a part into the Azure, or not Azure, into the IoT suites as well. So you have a part to play. So it's not everybody. Developers, regardless of whatever you do, are going to have some part to play in this story as it grows, and it's growing by leaps and bounds now. So, to date, I've worked on 2 major IoT projects, and they've both been really, really fun projects. But in 2 years, I'll probably be bored of IoT and won't want to do it anymore. But like at least commercially. But I like to play with these kinds of things too, the boards and stuff. So fun times. Any questions? There's my setup for my last time I did this demo. There's the pink castle, and there's the police and the bear that I talked about. So I did take a picture of it. So that's what we covered. If you like me, you can follow me on Twitter. I've posted all kinds of junk about stuff on Twitter. Kevin will testify to that. But no questions. I must have done a really good job of explaining this then.
So, I did have a question about the cloud side of things.
Sure.
So, like, what, especially with Azure, like, what is the cost of it? Like, how much does your, like, what are the things that you pay for in this demo? This demo, I've used a free service bus. The storage is like 10 cents a gig per month, and I used I'm maybe using a megabyte, so that cost me about a penny. I'm using a consumption plan for the serverless side of things, so that's basically 1 cent per minute. They round down, so free essentially. SendGrid is free. So on Azure, I'm basically the only thing I'm actually paying for, I think, is the service bus, which I think is like, because there wasn't a free tier for that would support this. There is one, but it doesn't support queues. So, but point is, it's so cheap to do IoT like this. It scales really, really well, and it doesn't get astronomically expensive. That's kind of the point. That's why a lot of folks do it this way, is because the supporting infrastructure is so cheap to run that you can literally scale to millions of devices and not break the bank doing it. But if you had to spin up all the infrastructure yourself, like imagining creating virtual machines and all the infrastructure to manage virtual machines and all the software to manage all the IoT devices and all that, how much that would cost, I can't even imagine. It wouldn't be cheap. So the storage and all that. So these serverless options that these managed solutions and serverless options that you're doing scale well, and generally speaking, they're dirt cheap. So for this demo, I might have spent a penny. So
you mentioned 13 trillion, 13 trillion, right?
Mm-hmm.
So how about the job market in this area in the future?
The top market?
The job market for students.
The job market. The job market is going to be, my thinking around this is that the job market for this is not going to be so much in the IoT space per se. It's going to be more on the AI and data side of it. The reason I say that is because these things are about generating data, and the value these things add to any organization is not so much the hardware; it's the data that the hardware provides. So the job market for this is probably going to be more on the data, to collect all the data these things are gathering and analyzing that and applying the AI to it. So if you're really interested in that side of things, I would focus on the data side for job market wise, because that's just that you hear a lot about it, but a lot of the data demand is being driven by IoT, and just but a small fraction of that IoT demand is actually for building hardware. I mean, there's a place for that. It's just mostly on the data and AI analytics side, because that's really where businesses want folks, is in that space. So
There's a blog post somebody did where they actually did the same kind of setup. They thought that somebody was sneaking into their into their swimming pool when they were not around. So they did the same thing. They did connected a the camera to the Raspberry Pi, connected it to. They were using AWS, and they used recognition, which is AWS's image recognition AI software, and they had to really they had the same problem because they would get like 1 million images every day.
yeah,
And so they basically hooked it up with recognition and then trained the model to pick up humans. And as opposed to and also not like the mailman or whatever, the actual intruders. And they were able to within a few days able to get it down to where they were able to capture the guys who were breaking into their house, into their backyard, just by using. So I don't know if Azure provides a recognition type of service.
It does. So. I thought about because again, you can go crazy with this stuff. For this demo, I didn't want to, but I actually in building this, I thought about building a facial recognition or using a custom image model on Azure to do the same thing. But yeah, you could do very much facial recognition. If it sees me, it says "Hello, Blaze" or something like that. I thought about going down that road, but I was like, I need something that I can write and not spend all week doing it. Because you can really run them up with this, and it's a lot of fun. Don't get me wrong, I love doing it. It's just I just needed something that was.
I mean, the point I was trying to make was that even the AI side of it is available as a service,
right?
To hook up to the other end of the.
Yeah, the enterprise side of it, the AI side is, but it's knowing how to build that, which is
how to train the model.
Yeah, how to train the model, and then how to build the software to handle all that kind of stuff is a big part of the IoT. Like I said, the bigger part of IoT is not the things; it's the internet, and it's the data particularly. That's the biggest part of this. It's not. I mean, the boards and stuff are cool. Don't get me wrong. It's just the money's in that data, the data side of it. So that's if you want to work in the space. But it's staring at tables and spreadsheets and lists and all that all day long is just not as cool, not as fun, I guess, for demos. There's another cool video. I don't know if you've seen it, but a guy he did, Mark Rober. You guys know who that is? He's a YouTube guy, and he did a glitter bomb IoT thing. Yeah, if you probably saw that, it made headline news. But he used the cloud to track people down that stole they were stealing packages. So basically built a bait package that had phones in it, that had cameras on them that would upload data to the cloud. And it could use the phones to track the people and all that, built a custom board for it and all that. I mean, you can go crazy with this stuff. But the point is someone stole the bait package and then they open it up and they just got the spray of glitter. And if you've ever tried to clean up glitter, it's not easy. I mean, that stuff gets its stuff, and it doesn't come out. It's
gift that keeps on giving.
Yeah. I have 2 little girls, and they got stuff with glitter on it, and it's all over the place. And any other questions, comments, confessions?
Have you worked in the other competing products like Amazon's or Google Cloud? Or
Just in general?
No, for IoT.
I honestly haven't. I mean, I haven't. I know I've looked at the product and but I have to say I've maybe kicked the tires on it. Maybe, but not done anything real.
I just wondered if you'd done it like a compare and contrast thing.
Feature-wise, it's depending on what aspect you're talking about. Depends on which one's going to do a better job of it. So, I don't. I think that so it's really, what do you want to do, and which one is going to be the best fit for that solution. So I've gotten called into most of the jobs I've been called into is because I'm an Azure guy, and so it's all the stuff downstream of the IoT solution that I get called in for. It's not so much the IoT stuff. I kind of learned that as an aside to doing all the other integration work, using services and functions and data stores and databases and all that other kind of stuff on Azure. And the IoT stuff was just kind of an afterthought because it was really the data. That's where all the data was coming from. But I mean, like I said,
that goes to his question about
Yeah.
jobs. That's the vast majority of the jobs in this space are not on the edge.
yeah,
Right?
it's in the data and the integration, and it's so if you really like, that's why I say the Internet of Things is more about the Internet than it is the things. So yeah, there's 20 billion devices, but those things are collecting a whole bunch of data. I mean, I captured 50 images in 10 seconds or whatever that was.
Yeah.
So, I mean, and it sent me 4 messages. So you can really crank out a lot of data with just a simple setup as this right here. And then you got to have someone to consume that data, filter it, analyze it, and do all that. So, and integrate it and make intelligence based around it. So.
I think the really cool thing about this space is that someone like me or you that might not have ever had a chance to, work with this kind of technology, you get the chance to do it. Like we prototyped a board that eventually we sent to electrical engineers, and they sized it down. But we were able to plug in, LTE networking and Bluetooth, and built a store to go in a device to go into 250,000 stores. And it was this ugly thing, a big box that got sized down to, a quarter of a credit card. In the end, we didn't do all that work to scale it down, but we built the prototypes, the big ugly shoe boxes, and then built all the core networking stuff, and then we paid someone else to size it down and customize it. But I got a chance to work on the ugly shoebox, and then all the core stuff in the middle, and I would have never been able to do that.
And the great thing about these boards like this, Raspberry Pi and Arduino, is their documentation for these things is really good. There's a lot of SDKs for them. Well supported. This community for Raspberry Pi is amazing. So if you have a problem, you can almost find somebody that will tell you the solution for it.
Yeah.
And they've got backwards compatibility going back to the original one for most of the OSs. And you can buy the boards themselves are like $25. They can be powered off a USB power supply, crossover cable into your laptop for internet, or just plug it straight in your switch. You can plug it into a monitor and have a keyboard experience if you want it.
We're gonna get the Raspberry Pi Zero W.
Yeah.
Right, which is like
wireless. Yeah.
Half the size of that board, and it's like $10.
Yeah.
Crazy.
And then you can buy all the GPIO array here. You can get the sensors for it. It comes with all the sensors you have on your phone, right? You have cameras, you have infrared sensors, barometers, accelerometers, name it. I don't know. What else does this thing have on it? Clocks, cameras. So what? Barometer, yes. Yeah, like there's a project out there. You can build a weather station out of a Raspberry Pi, and you can use it. You can actually register your weather station with the National Weather Service, and then they will put your dot on the map for your weather station, and you can participate in scientific research just by building a weather station from Raspberry Pi. I mean, there's
a kit for a basic station, including the Pi, was like $50.
I think I paid mine. I bought one of the original ones back in like 2012. I think I paid $75 for it then, but now they've got nothing but cheaper, and so you can get and like.
I think with also the power consumption, I think that's where like you can like the Raspberry Zero or
Yeah, Zero is like
so
amazing.
you can just run it off a battery for like weeks or months.
Yeah, this I have a battery. This right here is a 3,500 milliamp battery. I can run that Pi off of it for about 5 hours or 6 hours. But this is just this little battery.
But like if you were talking about application like weather station and stuff, you don't want to go and change it every 5 hours.
Yeah.
So like having
there's actually a PoE set up for this too, and it's got a dongle that you can do a PoE to it, and then it'll split the PoE, and then you can plug the power into that, and then you have your Ethernet. So you can power it over Ethernet without having to run 2 cables. I mean, that's one solution too as well. So there's a lot.
What's your yellow cable?
This is my Ethernet cable.
Oh, all right.
And this is my power cable, and this is the one I've got a USB webcam hooked up to as well.
Right, I figured that's what the black one was. I just wondered why you had 2 cables coming out.
Oh, this is for the network. I don't have a Wi-Fi adapter for this. I actually do at home. I didn't bring it, but
I thought you were bridging to the laptop.
I am. Ethernet is bridged to the laptop, and then I've got my wireless here, and so that's how this is connected to the internet. I just do internet connection sharing on my laptop, so yeah, low tech. So
Works.
yeah.
Simple.
Cool.
Questions, comments? I think you're pretty all sort of lead anyway. So
Thank you very much.
yeah, my pleasure.
Thank you.
If you like this content, please consider visiting us online at www.wintellect.com, and there you can find about services that Wintellect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintellect on Twitter at WintellectNow or at Wintellect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintellect.com. Until next time, thank you.